All right, part two of today's lesson from Friday 9/17. So I referred to the exercise that we did in class today. This is it, and the document is attached in the email. So they give us the definition of work. Work is done when a force causes an object to move in the direction of the force. And so, as I said, it requires two things. First, you have to have a force that's applied to the object. And then secondly, the object must move in the same direction as the force that's applied. So this is the little demo exercise that we did in class, a similar variation of what I just did a moment ago. On page 2, which these are numbered on the document you have, you are going to do number 4 here. And all you're doing is considering these scenarios, and you're going to determine if work is done or not. So you'll do that. And then, I didn't number these pages, but the one that you have will have page numbers on it. So it's page 3. You'll do the circled items on page 3. And this is a throwback to yesterday's lesson on kinetic and potential energy. So if you will go back to the note page that if you were here, you got in class. If you were not here, that I emailed you yesterday, you can revisit this information or this note page to refresh your memory to answer these questions. On the next page, we were considering the relationship between kinetic and potential energy. So you saw this in the energy skate park simulation, where your skater at one position had more or less potential and kinetic energy dependent on where they were. So potential energy is contingent on mass. Oh, you can't see that. Mass, gravity, and height. Right? So let me come back to the note page. Right? Potential energy has to do with mass, gravity, and height. Well, gravity stays the same. So in other words, we're looking at mass and height. So the higher you are, the farther you are from the ground, the more potential energy you have. So at the highest point, the skater has the highest potential energy. It means he's also moving the slowest, so he has the least amount of kinetic energy. As he comes down, he or she, when they get to the bottom of the skate bowl, they don't have any, if any distance, very little distance from the ground. Therefore, their potential energy is the least. They're traveling at their fastest rate of speed, so their kinetic energy is at the greatest. And then as they go back up the other side of the bowl, when they reach the highest peak, that's when they have the highest potential energy and therefore the lowest kinetic energy. So I did number 1 with the class. At this place, the highest point is where he or she would have the highest potential energy and the lowest kinetic energy. When he falls to the ground or closer to the ground, he'll have the highest kinetic energy because he'll be moving the fastest, and the lowest potential energy because the height will be the least in terms of distance from the ground. So then you complete 2, 3, and 4. Same principle. You'll also do this page, page 5. Same thing. You determine whether it's an example of kinetic or potential, and here you're analyzing A through G to determine the maximum kinetic energy, maximum potential energy. This part I think is self-explanatory. And then finally, today, we explored mechanical energy. So there are a couple of things I need to tell you about this, and I'll give you a couple of notes here. We started by talking about the law of conservation. Anytime you see this root, law of conservation, this part always means the same thing, that whatever it is can neither be created nor destroyed. So right now we're talking about energy, which means energy can neither be created nor destroyed. In other words, whatever amount of energy you start with, you're going to finish with. Energy can only be transformed, so it can't be created or destroyed, only transformed from one form to another. So, if that's the case, then we looked at a particular type of energy today, which was mechanical energy. And mechanical energy was the sum of kinetic energy plus potential energy, both of which you explored yesterday in class. So another way to write that is that ME, mechanical energy, is equal to PE plus KE. So the sum of the potential energy and the kinetic energy will equal the mechanical energy. The key to this is, because of the law of conservation of energy, the fact that energy can neither be created nor destroyed, if we neglect air resistance and friction, then in a system, this number will always be the same. That seems abstract, simply written on this page, so let me show you what I mean. How about this? We've got another skate scenario. All right. So what I just stated was that in these scenarios, we're going to neglect air resistance or friction. So all the energy that we start with will be all the energy we end up with, which means that mechanical energy that I have here, I'm going to have that total amount of mechanical energy as position 2, and that total amount of mechanical energy at position 3, because none of the energy is going to be lost, but it can be transformed between potential and kinetic energy. So at position 1, where he's closest to the ground, he has no potential energy, which means all of this has to be kinetic, because potential plus kinetic gives us mechanical. In position 2, 7 joules of the mechanical energy is kinetic, which means the other 8 has to be potential, because potential plus kinetic equals mechanical. And then finally in position 3, where the potential energy is 15 joules, then none of it must be kinetic, because we can only ultimately have 15 joules of mechanical energy. So then students did number 2 right here, and number 6, and number 7. Okay. So I would like for you to try those. That whole packet, we pretty much went through the ones that I just said and completed that in class today. So that is fair game for a notebook check. So you'll want to make sure that you have that done, and let me see it just to make sure that we're on point when you return. All right. Hope you have a great weekend. Please let me know if you have any questions.